Good morning, Kaushik.
Is it audible? Yes.
Yes.
Okay. All right. So, perfect. So, what we discussed so far, we just deployed our application top of Apache Tomcat, and how to do that Apache Tomcat configuration. So all the steps we have done so far, and again we have done the CI/CD pipeline, right? So this is also we have done so far. Okay, cool. So today let's kickstart the containerization. Meaning of that Docker. Okay, so let's try to kickstart Docker and Kubernetes as well. So before understanding Kubernetes, Docker, that is the prerequisites. Okay, we need to understand the containerization. Docker, it is the dependency before understanding orchestration. All right. So what is meant by Docker? Nowadays, it's highly demanded tool, I would say. Even most of the cloud seller also they are offering containerization. When if we want to deploy any application, they are they are advising us to go with containerization to achieve the cost effect. Okay, so in terms of spinning up new virtual machine and deploying your application, let's consider you do have application. For that applications, we want to do the replica size. Might be I need a 20 server. You think about the cost. So if I'm choosing T2 small, right? So you can calculate your, the cost per month. So in terms of spinning up 20 dedicated server, you can spin up 2 server or the max 3 server. Top of this, we can able to deploy 20 containers or 30 containers. Okay, container which is equal to server, right? So that those part, we are trying to understand. So Docker, which is nothing but this is Docker Inc. product they introduced in the market 2014. Okay, so we started to working with the container since from 2014, right? So the Docker, they do have their own architecture. Ideally, when you go for virtualization, so normally when you go for virtualization, right, we do have the hardware layer, right? And top of the hardware, you can install your base OS, right? And top of base OS, you can install any hypervisor or VMware, something you can install. And top of hypervisor, we can create multiple, I mean, based on your hardware optimization, we can spin up your guest OS, your virtual host, we can spin up, right? So it is the generic structure when you follow, virtualization pattern. Alright, so when you go for virtualization, so ideally we used to follow this structure. Again, let's consider in cloud platform, you can able to, I mean, we are paying for this virtualization. I mean, for VM level, we are paying, we are not going to pay for this hardware. If they, they're having 10 guest OS on top of single hardware, that is, absolutely who is going to manage? The cloud seller going to manage. But being as an end user, when you are trying to creating the EC2 instance, we are paying only for this, right? So all the virtual machine, which is running on some types of virtualization platform. You can see here, right? So any virtual machines. Okay, let me go and if you want to spin up any virtual machine, you can see it is virtualizing, virtually you are deploying. I mean, top of your so this concept we can call it as bare metal. Okay, so bare metal, which is nothing but we don't have access to choose your hardware. So they do have centralized hardware top of you can spin up, and you can consume based on your hardware specification based on your requirement. Okay, so ideally, if for if you have if you require 20 server, for each server approximately per month, if you are paying 400 USD dollar, you think about into 20, right? It's a huge amount. It is consuming kind of huge amount. So that's the reason we are preferring to go with the containerization, right? So when you go for containerization, it does unique architecture. So here also we do have hardware. Here also we do have hardware, and we require the base ways. And top of this base ways, again the same layer will come, which is hypervisor. And top of hypervisor, here we can call it as daemon. So daemon, which is nothing but it's a kind of virtual engine. How we are using right, how we are using a virtual engine, right? So that we can call it as a daemon, so which is using by Docker, right? And top of the Docker, you can spin up multiple containers. You can spin up multiple containers over here. So ideally, containers, which is nothing but, as I told you, it is equal to server, right? You can spin up multiple container. How can we able to spin up multiple container? So here, when you go for spinning up of your virtualization, virtual server, minimum, we require 4 GB RAM for each virtual machines. If you want to spin up, minimum we need 4 GB RAM. And 1 second. So here you just come up. So minimum what we record in the sense here, I would say 4 GB RAM we record. And if you go for hard disk, if you go for Windows in the sense, minimum 30 GB, right? Or Linux in the sense, minimum 8 GB hard disk we record only for OS. Okay, apart from that, based on your requirement, you can do upgrade or downgrade based on your requirement. That is secondary. But at this point, you can understand, if you want to spin up any OS layer, the guest OS layer, minimum requirement of your RAM, which is 4 GB, and your hard disk size, which is 8 GB. But when you go for containers, the RAM minimum, it should be 100 millicore would be fine. If you do have i7 processor, so if you go for i7, how many millicore will be there when you go for i7? So 1000 millicore is equal to 1 core. So here 7000 millicore is there. Out of 7000 millicore, you just reserve 100 millicore, and RAM size would be 1 MB. It is sufficient. Or you can reserve 4 MB, not even GB. So RAM, it should be minimum 4 MB. And your hard disk, the volume size, you can for OS OS size, it would be, I would say, 160, minimum 160 MB is required to spin up of your OS layer. So these are, you can see how much of difference in terms of consuming 4 GB and 30 GB, 8 GB for your OS disk to spin up. If you go with the containers, 100 millicore would be fine, and 4 MB of your RAM and 160 MB of your OS. So that's the reason it is, consuming very less hardware optimization. So if it is consuming very less hardware optimization, you do have the space to, deploy multiple containers over here. So that's the reason most of the cases we are preferring to go with, containerization. And here, when you want, if you want to release any upgrade, let's say now version 1 which is running. So in this week we do have one more release. So what ideally we used to do, we do have downtime. When you go for, virtualization, we do have downtime. But same when you go for containerization, we don't have downtime. So during I'm talking about in the production. Okay, in the production, the version 1 which is running. So if using by version 2, if you want to replace the version 1, we don't have downtime. So ideally, we can achieve the 99.99 percentage of your up and running, right? So that is huge advantage, I would say. So the end user will not get affect when I'm releasing any patches or your application. If you want to upgrade any binaries, you don't have downtime over here. So ideally we can replace when if it is in container platform. So that's the reason most of the cases we are preferring to go with containerization. Nowadays you can see that even when you go for cloud platform, they do have their own containers tool, which is ECS, Elastic Container Services. For orchestration, they do have EKS, Elastic Kubernetes Service, right? So again, so to manage of your application, it's very simple. You just write it down the script, you can trigger the script. So it's gonna be affecting all the layers which is belongs to that the respective application. So Docker, it's gonna be act as the interpreter between orchestration and the your base OS layer. So now let's try to understand Docker image. So you can see the architecture, how it's floating. Yeah, see this is the flow, so now ideally in Jenkins machine itself, we need to create as an image. So when I say image, which is nothing but in that image you can specify your container OS layer, and you can specify your web server, and top of you can deploy your application. So all these three package, all these three components you can put into in a single package. That naming conversion we used to call it as image. So that is what they are building as an image. Once built, they will push and Docker, it has their own repository, remote repository. So the Jenkins, what it will do after build it as an image, it will push the image into Docker Hub. So once push that image into Docker Hub, now you can deploy the Docker tool top of any server, and we need to make the interconnection between remote repo and the local server. So how it's communicating between each other, we need to generate the certificate policy. So using by that certificate, it will get that security authentication between local server and your remote repo, right? So once if you configure that certificate, it is pulling that image from your remote repo into local server. So now you can see that from the image, once downloaded that image, from the image it is spinning up multiple containers. Then this container, if you want to take backup, again we do have one more layer, which is registry. So it is generic architecture. Practically we are going to understand. So this is your virtual machine, right? So top of your virtual machine you can see multiple containers. When you go for containers, your application architecture should be microservices. So entire, which is for physical server, right? Sorry, monolithic, which is for physical server. Entire application architecture, which is belongs to virtual machine. Microservices architecture of your application, which is belongs to container. So entire and monolithic will not support to deploy on top of container. You need to convert it as a microservices architecture. For serverless, you need to convert it multiple APIs. Then the API will call to different components. That is quite advanced technology. Still, it is. I mean, they are trying to understand the serverless architecture. But I would say more than serverless architecture, container, it is kind of the best to manage for updating of your patches or to taking the backup. It's a kind of server, right? So ideally, what are the activities which we were doing with your virtual machines, right? So same activities, it's gonna be applicable for container layer. But again, when you go for VM, we used to work with the ad hoc command, but when you go for containers, these all are based on the script. Okay, so now let's try to understand the real-time flow. Okay, in the real time, how the flow will be. So ideally, already here we discussed the architecture, right? So okay, so let me create the architecture over here. So here we do have GitHub, right? So GitHub over here, and once you push to the code, and here Jenkins will be there. Okay, and next to that your Docker Hub will be there. Okay. And from the Docker Hub has to be connected with your Kubernetes. Okay, so under the Kubernetes, we do have, I mean, on same compute itself, we do have Docker and Kubernetes. Real time, I'm just telling you. Okay, and yeah, so then here Ansible will be there. So this is the flow. Okay, so how are we going to make the integration between all these components, right? So already, as I told you, the Jenkins, it has two types of pipeline: scripted pipeline and one more declarative. So far we are discussing declarative pipeline. Manually we are doing all the activity, and one more pipeline also which is available, consecutive pipeline. Okay, so ideally in the real time, we used to prefer scripted pipeline. So when you go for scripted pipeline, we should be aware of Groovy script. Without having knowledge of Groovy script, we cannot able to build the pipeline using by script. Ideally, in the real time, we do have a centralized script over there. So based on your application, do the changes with your respective parameter and build a pipeline accordingly. So that is what it is happening when you go for scripted pipeline. So scripted pipeline, which is nothing but it is automated. Okay, so based on your application, you can pull and do some changes and trigger the script. It's gonna be building, the CI pipeline. Okay, so ideally in real time, for CI, I mean the continuous integration pipeline, how can we do the automation using the Jenkins file? So we do have the Jenkins file. Using by this Jenkins file, we could able to do the automation for CI. So when I CI and CD. So this CD, which is nothing but continuous deployment. Okay, so once if it is built as an image, it will push that image into Docker Hub. Now here Kubernetes and Dockers are there, right? So how about continuous delivery? So for this continuous delivery, again, we do have multiple tools for continuous delivery. One which is Spinnaker and Octopus. These all we are not going to study, but I just want to explain the real-time flow. Okay, it is a different curriculum. Spinnaker, Octopus, these all are, licensed. It is not open source tool. So these all are, continuous delivery tool. Okay, so here, how can we create a continuous delivery pipeline? In the sense we used to call it as dingy file. So using by this dingy file, again, we can do the automation, for continuous delivery. So if I push that image, immediately the dingy file will monitor. It has to be deployed on Spinnaker. Okay, the Spinnaker, it's gonna be monitoring of your Docker Hub, and you can schedule probably, coming Saturday, just want to release this new version image into this production environment. You just schedule it over there, then accordingly Spinnaker or Octopus tool will fetch the new version from the Docker Hub and will deploy it into this top of your orchestration and containerization as well. So you can see that widely we are using continuous delivery tool, which is Spinnaker, right? So you can see, so this tool, I mean, you can see here. So if I go and schedule immediately, the dingy file, it's gonna be triggering all the automations for deployment, I mean, delivery. And Octopus also we are using. Getting my point? So a dingy file will looks like this, dingy, sorry. Yeah, dingy files. So you can go through it in Okuri profile. They used to mention, will you be aware of dingy file? Will you be aware of Jenkins file? How to write, right? So this is, dingy file. So dingy file again, it's absolutely based on Groovy script. So we can write it on over there based on our condition. We can pass the functions, parameter, classes as well. And the Jenkins file, yeah, so it would be like this, right? So ideally, using by Groovy script, we can write it down. All right, for understanding perspective, I'm not going to cover in this curriculum, so it is different batch, but I just want to show you how can we write Jenkins file and all the stuffs. All right, so let me show you. Right, so here, yeah, dingy file. Okay, so here you can see, so the dingy file looks like this. So it is for a different batch. I just take it. Okay, it's not. So yeah, so this is the dingy file. You can see that I specified a Docker image artifact. Okay, and it is pulling that image of, the recent build which it is happened. It is pulling that recent image from the Docker Hub. So once if I, return and deployed into this Jenkins, the Spinnaker tool, then it's gonna be automated. So if I do any changes, I just go back and see the changes with your respective application and schedule over there. Automatically, the script it's gonna be do the activities. Getting a point? And you can see that this is dingy file, and you can see the Jenkins file. So these are ideally quite important, I would say. You can see that I just mentioned, the stage 1, stage 2, stage 3. So stage 1 has to pull and stage 2 has to analyze that strength of your image, SonarQube, Veracode. These all are vulnerability tools, right? And you can see Veracode, these are right, scanning of your image, then start to build an image and pushing that image into the Docker Hub. So ideally, I just given the steps over this scripted pipeline. This is what I was telling, scripted pipeline. Okay, so right now, we are not going to spend it because we don't have timeline, and it is a different curriculum. So how to write all the stuffs. Okay, so now this is the flow. You can see that. So once you push that image into Docker Hub, and in real time, you can see this all of the tool, it is necessary, has to be there. Okay, and if I can write it on the script over there, then what are the changes if I'm doing, you can schedule it over here. Accordingly, it's gonna be deployed into the production. If you want to spin up, I mean 500 containers is running right out, which is an existing platform. So if you want to change a version 2, it's a matter of second. It's a matter of second. So we don't have downtime. So that is the beauty. We are looking forward to this architecture. So ideally you can achieve cost effect. It is not impacting your business, right? And to manage of your environment, it's quite easy. Any questions so far? Any questions?
So the dingy file, you don't need dingy file knowledge in just doing DevOps.
No. We record. That is what I was telling. See, so far what we are doing in the sense of we are doing some manual activities over here because initially if I'm started to writing that scripting, you will not understand the concept. So far what we are understanding in the sense of manually how can we make the integration, how which is triggering, but in real time manually activities it's quite less, right? So all are they're expecting the automation. So how can we do the automation in the sense using by this Jenkins and Dinky file, using by that we can do the automation. And again we do have some additional tool as well, Spinnaker, Octopus for delivery, Veracode and SonarCube to check the vulnerability strength of your image and yeah, so these are multiple tools, so we can integrate to do automation for your CI/CD pipeline. So I will never say if you're not being aware of Dingy file or Jenkins file, are we able to sustain in the DevOps? Not like that. Okay, again, based on the project, based on the organization, if there is requirement, you have to understand there is no other option. But if it is a very advantage. You can, able to manage very easily.
Okay, thank you.
Yeah. Did you understand the flow? So now we are going to understand Docker. Once we understand the Docker, let's try to understand Kubernetes. Okay, so Docker, which is the dependency for Kubernetes. Kubernetes again, it is a 28 hours course. Okay, but in this curriculum, we are going to spend only 10 hours. So who want to understand CKA? I mean, certified Kubernetes administrator. So Kubernetes, it has three, paper. One which is CKA, certified Kubernetes administrator, and another one which is CKD, certified Kubernetes developer, and another one CKS, certified Kubernetes security. Right, security still in the market, it's a very less we are using, but CKA, CKD, it's a very demanded. So myself, I certified in CKA. Okay, so here the exam cost would be 31,000. Okay, the exam cost would be 31,000. CK is very demanded tool. So CKA, okay, let me show you that synopsis as well for Kubernetes. So this is a complete Kubernetes platform. So at this point we are going to understand this part. Okay, so we are going to spend 10 hours, but when you go for the dedicated curriculum for Kubernetes, you have to spend 25 hours. So in this 25 hours, all the stuffs we are going to understand. Because how to writing the Helm chart, these are very important. Using by this Helm chart, we can integrate multiple components. Let's say if you do have stateful set application, right? So from the load balancer to till backup, how can we do for your microservices, right? So if you understand the entire concept, then you can go for the certification. So you just Google it, what is the demand for CKA, right? So nowadays 90% of organization, they're moving forward to orchestration. I hope already you know that, right? You, even if you go for AWS cloud platform, they are preferring EKS, If you go for Azure platform, they are preferring AKS, and GCP, we do have GKE, right? So all are, we are moving to orchestration. So achieving cost effect, again, security, it is a Google product. Kubernetes, it is a Google product. They introduced in the market 2006. We started to work with the Kubernetes since 2014. Southern Asia, we started to work with the Kubernetes, since from 2014. But there is no competitor for Kubernetes. Docker, they have introduced orchestration tool, which is called Docker Swarm. But Docker Swarm, it is not at all recommended for the production. Kubernetes only, it is recommended for the production. So there is no competitor. You might heard about OpenShift. That is the IBM product. I was into that in this project. Okay, so OpenShift, it is a Red Hat product, IBM product. Okay, so when you go for OpenShift, again, behind of Kubernetes only, which is running. So what's the major difference in the sense of, Kubernetes, that is open source. OpenShift is not a open source, but OpenShift, they are providing the GUI. Okay, so you can, over the GUI itself, you can write it on the script and you can monitor quite easily. So OpenShift, behind of, they do have Kubernetes. When you go for EKS, behind of, they are having Kubernetes. So there is no competitor. It's a Google product. When I say Google product, you can think about the security. So always Google will focus the security, they'll give more preference for the security platform. So ideally, Kubernetes are very demanded, tool, I would say. If you know that Kubernetes, it's I would say very quickly you can able to switch over. If you're planning to switch over, very quickly you will get the job as well. Even I can refer. So much of openings are going on. So this is, this is what we are going to understand in the flow. So for next 15 to 15 to 18 hours, we are going to spend these two tools because it's very important. Okay, so this flow at this point, yes, we are not going to understand Spinnaker and Octopus. So now, right now we are here. Now, how can we write it down the script to convert it as an image? And how can we push that image into Docker Hub? And once if you pushed, then let's try to spin up your, Docker. Make sense? Any questions so far? Cool. So, so the Docker, it has 3 package. Okay, so Docker, it has 3 package they are providing. One which is Docker file. Okay, and second one which is Docker Compose. Docker Compose using by .yaml script, and third one which is Docker Swarm. It's a cluster platform. Okay, so they're providing 3 types of package. Using by these 3 package, we could build your the stateful set environment. Let's see, using by so using by Docker file, you can create as an image. So here you can build as an image. You can see the connectivity, and once builded that image using by Docker Compose, you can integrate. Multiple. Let's say here I just built an image for Apache Tomcat, and for instead of Apache Tomcat, I deployed application. Now I want to integrate with the MySQL database. Okay, so see, we do have 3 components, right? The 3 components we need to spin up as a container. Altogether, all the image, we can put into in a single file, which is using by Docker Compose. So if you do have multiple image, if you want to integrate, between each image, each container using by Docker Compose. Now for each container, I just want to define the replica size. For Tomcat, I need 10 container. For DB, I need a 2 container. So using by Docker Swarm. So here we can build container cluster. So using by this 3 package, we could able to build as an the containerization platform, this two. And this is the orchestration. But instead of using Docker Swarm, we are going to understand Kubernetes. But Kubernetes already it is replaced with the Docker Swarm. So Docker Swarm in the real time we are not using. It is a Docker product, but it does not have much responsibility. Let's consider internally. See, externally you can create the load balancer. Okay, internally for your microservices, how can we create the load balancer? How can we create the DNS? How to monitor your microservices, right? So how to define the resources? Let's consider, I just want to define the 100 millicore for your CPU. If it is reached or 90% of usage, who's going to trigger? How can we integrate with your service node tool as a ticket? All these stuffs, Docker Swarm is not supporting, but Kubernetes it is supporting. So you just deploy that microservices. You do have a monitoring tool, which is nothing but Prometheus. Okay, using the Prometheus, you can capture all the metrics from the pod. So again, how can we how the Prometheus is going to capturing the metrics? We do have interpreter, which is node exporter. Okay, so using by the node exporter, it's gonna be exporting the metrics from the microservices to our monitoring tool. Then the monitoring tool does not have the dashboard. Again, we do have Grafana, some visualization, Elasticsearch tool, Grafana or Kibana or Splunk you can use. Using by that, you can expose your metrics as you visualize, you can able to visualize those metrics. And then from there, you can integrate with your ticketing tool. At this point, I had experience, okay, so Kubernetes, it is integrating with the service now. So then you can generate as your ticket using by service now. You can define your P1, P2, and P3 ticket as well. So accordingly, you can manage. So there is lots of tool integration will be there. Okay, then ideally we could able to manage, right? Yeah. Any questions? Cool. So let's try to understand the Docker file. So when you are writing the Docker file, right? So it does the syntax. It does the syntax. We need to understand the syntax. When you are executing the command or when you are passing the parameter, how does it is behaving, right? So we need to understand, right? So let me give the syntax over here. When you go for Docker file, so before that you need to install the plugin at your local host. Okay. So what you need to do in the sense, first you just go back to, see already I installed a Kubernetes plugin and JSON plugin. So you just go to extension and first you can browse JSON. Okay, so once if you browse through JSON, you can see that JSON plugin. Okay, and YAML plugins also are there. You just go and install YAML. Okay, so YAML plugin also already I installed. So 2 plugins which is mandatory you need to install. Once after install this, then you can install Docker. Okay, so Docker plugins will be there. Okay, let me try to install the Docker plugin. All right, and Docker files. So Docker, yeah, Docker file validator, that's correct. So you need to install Docker file. So what are the, let me give the notes over here. Okay, so first one, you need to install JSON extension. All right, so second one, YAML extension. Third, Docker, and fourth, Docker file validator. And Kubernetes, you need to install. So let me show you. You just go back to Kubernetes. So Kubernetes extension already installed, right? Okay, and Docker Compose extension you need to install. You just go back here. Docker Compose. Sorry. Docker Compose. Fantastic. So already installed. And yeah, so at this point it would be sufficient. So these are the extension you need to install at your Visual Studio. Let me share over the chat box. Okay, so these are the extensions pretty much important before configuring Docker file. All right, and after installed, then you can you can create one folder and you can do you can start to write it down your script over there. Before that, you need to create one account in centralized hub. I stated right, Docker, it has two platform, one which is local server and one more which is nothing but your Docker hub, right? So you need to create a repository over here. Then when you want to pull the image, it's going to be pulling that image from Docker hub. So you need to create one account. You just go to dockerhub.com. Yes. So, all right. So let me, okay. Bicycle, I need to choose where it is. 1, 2. What happened? 1. That's all right. So verify. Field is required. One, 2, 3. That's all right. Okay, let me testing. So dockerhub.com. New customer subscription. Okay, so here already just created an account. Okay, so using by your Gmail address, you can create an account. So after created, you can see already the Docker officially they have created multiple images. You can see MySQL. If you want to pull MySQL image, see you can see that 3 hours ago they have upgraded. And if you want to see the size of your image, as I told you, right, it would be MB. You can see size of it is 154. Will you trust MySQL configuration file would be, who's having the experience with the database, you might be aware of minimum be required, 30 GB hard disk. You can see that 154 MB. So ideally, on top of one, virtual machine, I can able to create, 4 or 5 database over there. So it's a highly advantage, right? And we have done the Tomcat configurations, right? So you can see the Tomcat image which is there. So, and you can see that image size, which is right. So you can see that tag and that the size of your image 153 latest version. So like this, you need to create your own image. These are the official image. Official image would be considered as a dependency for your application. If you need Tomcat, you can pull the Tomcat. Okay, but instead of the Tomcat, how will you deploy the application? You need to create your own image. In that image, you need to specify, this is my application, this is my web server, this is my application server, it is my database. All together, you can convert it as an image. Then how can we share the environment variable? So let's say I do have Cockroach database or MySQL database, right? I do have front-end application. So the front-end application, whenever if I'm interacting, so it has to be sync up with all the live data has to be sync up with your, the database, right? So how can we add the environment variables into that application? And how to do the replication between two database, one DB if it is down, other DB has to bring up. How can we do that, replication, all the stuff. So let's try to understand. Okay, so these three these are the extension you need to install at your Visual Studio. Once you install, you can go back to create one folders over here. Okay, so I just want to create the, okay, let me go back. Let me create one folder. So let me use this folder already, which we used for GitHub, right? So let me use that same folder. Yeah, I just want to open and go to inside of the folder in desktop here, which is this. So if you do have any questions, please you can ask me. Okay, so here all these concepts are pretty much important. I'm just going to delete all the stuffs. Okay. Yes. Perfect. So now I just deleted all the file. Let's try to understand the Docker file. So the Docker file does not have any extension. It is a text file. Okay. Docker file does not have any extension. See, after you install the plugin, you can see automatically the extension is there. Okay. So yeah, it does not have the specific extension, but when you go for Docker Compose and Docker Swarm, it does the specific extension. It should be .yaml. So ideally, when you go for container layer, any scripting, if you're writing that file, we used to call it as Docker Compose, and while writing the script in Kubernetes, we used to call it as manifest file. And the Ansible, you might heard about the playbook, right? So all these three scripting file does extension. Using by that extension, we could able to deploy, right? So that's the reason I stated before writing any file, we record the YAML extension, because all these tools, basically it depends on YAML. But syntax will be different. When you're writing Docker Compose, it does different syntax. When you're writing, Kubernetes, manifest file, it does own syntax, and playbook also it does own syntax. Right. Cool. Any questions so far? So these are the prerequisites. You just install at your local host. So now I just want to explain what are the commands are we going to use. So any Docker file, all right, so any Docker file, if you're going to be create, it should be in the folder. Okay, it should be in the folder. So you should not keep at different locations. So ideally first we need to, okay, I would say here, create folder first. So instead of the folder, you can create a Docker file. So why I asked you to create the folder, in the sense, you may create multiple Docker file. So if it is in the same path, it will get conflict, right? When you are building as an image, if it is in the different path, while applying the build command, right, it will not get conflict if it is in the different path. If it is in same path, obviously. So when I'm passing the command, when the command it's going to calling that respective Docker file, so during that time, it's gonna be getting the conflict issue over there. So that's a reason. Once, if when you are trying to creating the Docker file, make sure the Docker file has to be in the different path for different application. It should not be the same path. So when the Jenkins, it's going to be triggering the CI and CD pipeline, Docker file has to be in the GitHub. So Docker file, once if it is in the GitHub, you can see that. I'll show you most of the application. You can see the Docker file should be in the GitHub. I will show you Docker file in GitHub. can see any applications, if they want to deploy, they used to all right. So you can see for this application, is there a Docker file? So then the Docker file, it's pretty much important. I mean, should be in the different path. Okay, it's a different. Okay, I just want to show you Java application deploy into containers. Okay, containers from GitHub. So you can see the architecture. So I'm just going to some repository. So here are we able to see the Docker file? Okay, let me browse it like this Docker file. Sorry, GitHub. It's not taking me to the correct website. I think so. Cool. So, so ideally, the Docker Hub has to be in the GitHub. Okay. So when I'm triggering the Jenkins file, it's going to be pull that. I mean, it's going to be pull the Docker file from the GitHub. So here, instead of the Docker file, first what we need to specify, that image name. What is your image name? Let's see if I'm going to use from command, right? So from command, yeah, see here, automatically the plugin, it is telling, do you want to choose base image for your container? Makes sense? So when I'm when I'm inserting the from command, it is asking me to choose the base image. Got it? So I can say to select, I can say to, okay, sorry, select the container image. So initially it may take time to understand, but if you have any questions, you can feel free to ask me. So from when I'm passing the from command, it's gonna be selecting the base image. Then I would say maintainer, right? You can see name of the image maintainer, author name. So I can write it down like this, maintainer. Okay, so maintainer, which is nothing but write author name. So author name, which is nothing but right now, let's consider Anand, he is writing this image. So the next version, Shiva, he's writing the image. The third, Sanjana, she is writing. So we need to specify that who is building that image. Okay, so then we need to use run. So when I'm choosing run, you can see that execute command inside a shell. Execute command inside a shell in the sense, while building as an image during the running time. Okay, so what are the packages do you want to install for this specific image? I just want to install Tomcat. I just want to install JDK file. I just want to install PIP package. So all these stuffs while building, how can we pull that from an internet, right? So run, I would say install package, right? During the, during the build state, I would say during the build state. So let me execute practically, then you can understand. Okay, so right now let's try to spin up on VM. Okay, so top of that VM, practically let me show you if I'm using from command, how it is behave, right? And maintainer, how it is behave. Let's try to understand. It has I would say around around 12 to 8, I think so, yeah, 8 or 9 comments are there, but quite important. Okay, so you need to understand the difference between all this. Any questions so far? So let me pass it till over here. So tomorrow what we are going to understand in the sense, let's try to understand for each command execution, because when you go for interview, 100% I would say they will ask you to write it down the Docker file. I have seen many participants, okay, so they used to say they have given the case study. They are asking us to writing the Docker file for MySQL. They're asking us to exporting the variables instead of the MySQL or instead of the Apache Tomcat, or how to write the Docker file for Nginx. Or they used to provide some dummy project. They will ask you to, write it on the Docker file. So it's very common nowadays. So we have to initiate that. Okay, so while initiating from maintainer, run, CMD, entry points, world names, blah blah blah. So multiple commands are there. So where can we insert? How does it is behaving? That's very important. We'll understand. Okay. Before that, before winding, do you have any questions? I will address those questions, or else let's drop up over here. We'll resume on tomorrow. Any questions?
Karthik, which scripting language we are using in Docker file?
YAML.
Okay.
Yet another markup language. So tomorrow I'm going to explain the structure of YAML. It has own structure. Cool. All right, guys, we'll meet up on tomorrow. Thank you all. Bye-bye.